Right now, roughly 57 million Americans across the central United States are living inside a 5-day window that severe weather forecasters have quietly begun calling something different. Not an outbreak, not a storm system, a corridor, a stretch of geography that, for 5 consecutive afternoons, has produced tornadoes, giant hail, and damaging straight-line winds along almost exactly the same line on the map. On Monday, April 13th, a rain-wrapped EF2 tornado carved through the southern side of Ottawa, Kansas, at 125 miles per hour. 14 more tornadoes were reported that night across Kansas, Minnesota, Iowa, and Wisconsin. On Tuesday, the Storm Prediction Center drew an enhanced risk corridor that stretched from San Antonio through the Midwest and into Buffalo and Boston. On Wednesday, the risk reloaded across Iowa and Illinois. And on this Thursday morning, April 16th, the same corridor is being drawn again. This is not one storm. This is an atmosphere that refuses to reset. Before we go further, I want you to do 2 things. Leave a comment with your current location and your local time, because when you see what's coming in part 3, your distance from this corridor matters. And stay with me, because there are 2 separate systems overlapping right now. And the most dangerous thing about this outbreak is not the tornadoes themselves. It is what happens when a meteorological pattern and a long-term climate migration meet inside the same zip codes. The real story is not any single tornado. The real story is the 5-day line. Start with what is already on the ground. Monday night, April 13th, 2026. A supercell tracked along a warm front draped across the upper Midwest and produced a rain-wrapped tornado that entered the southern side of Ottawa, Kansas, around 7:23 p.m. Central Time. The National Weather Service out of Topeka rated it an EF2, with estimated peak winds of 125 miles per hour. It stayed on the ground for 7.3 miles. It injured 3 people and destroyed or severely damaged dozens of homes and businesses. Municipal crews spent the next 48 hours clearing utility poles between 15th and 17th Streets. The same line of storms produced a second EF2 near Hillsdale, Kansas, where roughly 50 to 60 structures were completely destroyed or significantly damaged. 1 recreational vehicle was flipped into a small pond. An EF1 touched down in Lynn County. By the end of the night, the Storm Prediction Center had logged 14 preliminary tornado reports across 4 states. Tuesday, April 14th, was the headline day. The SPC issued an enhanced risk across a corridor stretching from Texas through Oklahoma, Kansas, Missouri, Iowa, Wisconsin, Illinois, and northern portions of the Northeast. Forecasters identified Wisconsin, Illinois, Iowa, Oklahoma, and Texas as carrying the highest tornado threat of the entire event. That corridor runs through Kansas City, Des Moines, Chicago, and Milwaukee, combined metropolitan populations exceeding 18 million. Wednesday, April 15th, the Storm Prediction Center reissued an enhanced risk zone again, this time focused from eastern Iowa into southern Wisconsin and northern Illinois. Warning of large to very large hail and a couple of tornadoes. Thursday, April 16th. Today, the SPC Day 1. Convective outlook valid through Friday morning still carries severe thunderstorm risk across the southern plains into the Great Lakes, with large hail, severe wind gusts, and a couple of tornadoes possible. That is 4 consecutive afternoons of tornado-capable storms along a nearly identical corridor. And forecasters are now tracking the possibility of a 5th round heading into the weekend. This is the anomaly, not a single outbreak day. A window that keeps reopening. Keep that in mind. We are going to need it. Every severe weather outbreak has a machinery section. This one is more complicated than most. The standard ingredients for a tornadic supercell are well known. Warm, humid air at the surface. Cold, dry air aloft. Strong vertical wind shear that causes storms to rotate. A source of lift, usually a cold front, warm front, dry line, or outflow boundary, to force the atmosphere to release that energy. What is happening from April 13th through April 16th, 2026 is structural. A large-scale, upper-level trough is locked over the western United States. It is sending a train of compact, low-pressure waves eastward along a stationary frontal boundary draped across the Mississippi Valley. Each wave is a separate storm system. Each wave arrives roughly 24 hours after the last. Each wave meets the same warm, moist Gulf air mass already in place across the Central Plains. Each wave releases a new round of severe weather across the same corridor. The Weather Prediction Center has explicitly warned that repeated rounds of severe thunderstorms and heavy rainfall could affect the southern and central plains, the upper Midwest, and the Great Lakes through at least April 16th as multiple low-pressure waves track along that frontal boundary. The dry line plays a specific role. It is a boundary that separates dry desert air from the southwest with moist Gulf air from the southeast. It functions as a trigger mechanism. It marches eastward during the day as daytime heating erodes the cap. Supercells fire along it in the afternoon. In this pattern, the dry line keeps retreating westward overnight and advancing eastward again the next afternoon. It is resetting daily. Then, after sunset, the low-level jet kicks in. A nocturnal band of fast-moving air at about 5,000 feet altitude accelerates over the Central Plains. The existing supercells, instead of dying at dusk the way convective storms usually do, get refueled. Rotation intensifies. Tornado risk extends deep into the overnight hours. That is why Tuesday's threat was described as extending from late afternoon through overnight. Individually, none of this is unprecedented. Wave trains happen. Dry lines reload. Nocturnal supercells are familiar to anyone who forecasts in Oklahoma. What is unusual is the persistence. 4 to 5 consecutive afternoons of supercell-capable environments across the same geography, driven by a blocked upper-level pattern that refuses to progress eastward. The ridge and the trough are locked in place. Until one of them breaks, the corridor stays open. But that is only the first layer of the problem. The second system is not weather, it is climate. And it has been moving for 40 years. Dr. Harold Brooks is a senior scientist at NOAA's National Severe Storms Laboratory. His research, along with work by Dr. Victor Gensini at Northern Illinois University, has documented a consistent long-term trend. The center of U.S. tornado activity has been migrating eastward. The traditional tornado alley, anchored across the Texas Panhandle, western Oklahoma, and western Kansas, has seen a measurable decrease in tornado days over the last 4 decades. Over that same period, the Mid-South, centered on Memphis and extending into Mississippi, Alabama, western Tennessee, Kentucky, Arkansas, Missouri, and southern Illinois, has seen an increase in tornado days of roughly 10%. This new zone has acquired a name, Dixie Alley, and a 2025 tornado season that produced 1,429 confirmed tornadoes across the United States placed the overwhelming majority of them east of the Mississippi River, right inside that migrating zone. The suspected driver is a shift in the dry line. As the climate warms, the boundary separating dry western air from moist Gulf air is migrating eastward. The ingredients for a tornado: warm, moist low-level air, cooler, dry mid-level air, and strong vertical shear are now converging more frequently over a region that includes hills, forests, and densely populated small cities and suburbs. Which brings us to April 2026. The corridor being hit right now is precisely the transitional zone: eastern Kansas, Missouri, Iowa, Wisconsin, northern Illinois. It is the handoff zone where the old tornado alley meets the new one. And because the frontal boundary is stationary over that exact transition, every one of these waves is depositing tornadoes into a population geography that includes Kansas City, Des Moines, Milwaukee, Chicago, and a continuous ribbon of small towns that were never the historical bullseye. Ottawa, Kansas, Hillsdale, Kansas, Amboy, Minnesota, Bloomington, Indiana, where a particularly dangerous situation warning was issued earlier this season. These are not the dots that would have lit up a tornado map in 1986. This is not a coincidence. This is pattern on pattern. A short-term atmospheric anomaly depositing its energy into a long-term climate migration. Two independent systems overlapping in the same geography at the same time. To understand what could happen, look at what just happened. From March 13th through March 16th, 2025, roughly 13 months ago, the Storm Prediction Center tracked a severe weather event that would end up setting records in almost every category. 118 confirmed tornadoes. The largest tornado outbreak ever recorded in the month of March. An outbreak intensity score of 147, classifying it as historic. A peak tornado rating of EF4 with winds of 190 miles per hour near Diaz, Arkansas. A long-track violent tornado through Walthall, Lawrence, Marion, and Jefferson Davis counties in Mississippi that killed 6 people. Tornado emergencies issued across multiple states. A Day 2 high risk from the SPC, only the 3rd ever issued. The final toll. 44 people killed across 8 states. More than 247 injured. Over 670,000 without power. $11 billion in damage. The costliest tornado outbreak in United States history, unadjusted for inflation. The 2025 outbreak shares 3 structural features with what is happening right now in April 2026. 1. It was driven by a large upper-level trough ejecting over the Rockies and sending energy eastward into a pre-positioned warm, moist Gulf air mass. 2. It was multi-day. The severe threat persisted across 3.5 days, with separate waves producing fresh supercells on consecutive afternoons. 3. It occurred along the same geographic zone that is active right now, the Mississippi and Ohio River valleys, the new Dixie Alley. The 2025 outbreak also produced something the 2026 outbreak has not yet produced: violent, long-track tornadoes. Nocturnal tornadoes crossing densely populated areas. The EF3 that moved across Greater St. Louis and crossed a Lambert International Airport runway while a plane was taking off. The long-track EF4 near 56 and Franklin, Arkansas. Could this April 2026 event scale into the same category? The raw ingredients are in the same range. An upper trough locked in place, a stalled frontal boundary, a dry line resetting daily, a low-level jet reactivating each night, a population geography that now includes the new Dixie Alley. The difference so far is that no Day 2 high risk has been issued. No violent EF4 or EF5 has been confirmed. The reported tornadoes have topped out at EF2. The similarity is that the atmospheric regime producing the outbreak has not yet broken down. And that matters. Because in 2025, the worst day of the outbreak was Day 2. Something is different about how this is being reported. A 5-day severe weather corridor cutting across the central United States, producing EF2 tornadoes in Kansas and severe threats reaching Chicago and Milwaukee, would in an earlier media era have been wall-to-wall national coverage. Right now it is being covered, but it is not dominating. And there is a reason for that, which is worth naming clearly. The Storm Prediction Center introduced a new communication tool in February 2026 called Conditional Intensity Groups, or CIGs. It was designed to distinguish between lower-end severe threats, like an EF0 or a 60-mile-per-hour gust, and higher-end threats, like an EF5 or a 90-mile-per-hour damaging wind swath. The stated purpose is to highlight the days when violent or extreme weather is more likely, so that emergency managers and the public can triage attention correctly. The April 13th through 16th corridor does not, so far, carry a high-end conditional intensity rating. It carries an enhanced risk, Tier 3 of 5. Significant. Not catastrophic. The communication system is functioning as designed, but there is a second-order effect. The outbreak is being triaged downward in national attention even as it produces a 5th consecutive afternoon of tornadoes and giant hail. There is another layer. The new Dixie Alley corridor, the transitional zone from eastern Kansas through Missouri and into the lower Great Lakes, is thinner in broadcast market coverage than the classic Tornado Alley. The original Oklahoma and Kansas corridor has been drilled, covered, chase-filmed, and rehearsed for decades. The eastern shift is into hills, forests, rural counties, small towns, and suburban sprawl where tornado visibility is lower, where shelter infrastructure is older, and where viewers are less likely to be on a first-name basis with their local storm tracker. There is a documented warning communication gap in Dixie Alley. Tornadoes in hill country are often rain-wrapped. The Ottawa, Kansas tornado on April 13th was itself rain-wrapped. Lead times shrink. Visual confirmation is harder. Mobile home stock is proportionally higher, and the storms are more likely to occur at night, which is the highest fatality ratio window in all U.S. tornado data. The outbreak is getting coverage. It is not getting the energy it would be getting if 125-mile-per-hour winds were moving through a suburb of Dallas or Oklahoma City on a sunny afternoon with clear visibility. That asymmetry is part of the compound hazard, which means the framework we use to prioritize emergency response is itself being outpaced. Here is where we arrive at the real problem. American severe weather emergency management is built around the single-day, single-event model. A day of outlook, a watch, a warning, a post-event damage survey, a cleanup. That model has worked well for 50 years, precisely because the atmosphere has historically obliged. Most outbreaks deliver their worst day and then move on. The March 2025 outbreak was 3.5 days. The April 2026 event is now entering day 5. A multi-day cyclic regime does 3 things that a single-day framework is not built to absorb. 1. It depletes response capacity. National Weather Service forecasters, emergency managers, utility crews, Red Cross shelters, insurance adjusters, and structural engineers are all finite resources. 4 to 5 consecutive afternoons of tornadoes exhausts the people who respond to them. The American Red Cross shelter at Hillsdale Learning Center was still open on Tuesday for Monday's survivors, while Tuesday night's storms were firing overhead. 2. It creates cumulative structural damage. A roof that survived Monday's EF1 gust is weaker on Tuesday. A tree that was stressed on Wednesday falls on Thursday. A saturated watershed from repeated rainfall shifts the damage profile from tornado to flash flood. Now, which is what the Weather Prediction Center has been warning about across the Plains and Great Lakes for this entire corridor. 3. It produces a decision fatigue effect in the public. The first tornado warning prompts action. The 5th tornado warning in 5 days prompts a shrug, especially in the new Dixie Alley corridor where warnings arrive often, and visual confirmation arrives rarely. And our models do not yet have a clean name for this. A persistent, wave train-driven, multi-day tornado corridor overlapping with a long-term climate shift is not exactly an outbreak. It is not exactly a season. It is something without a clean classification. A meta-event, extended forcing, a resonance. We are watching something that our old definitions were not designed to describe. That is not a small problem. That is the problem. So here's the compound hazard thesis in plain terms. System 1 is meteorological. A blocked upper-level trough, a stationary frontal boundary, a resetting dry line, and a reactivating low-level jet are producing 4 to 5 consecutive afternoons of supercell-capable environments across the same corridor from the southern plains into the Great Lakes. System 2 is climatological and geographic. The center of U.S. tornado activity has been migrating eastward for 4 decades. The overlap zone between the old Tornado Alley and the new Dixie Alley runs straight through the population corridor currently under threat. Individually, either system is manageable within existing frameworks. A 5-day persistent atmospheric pattern with no climate shift underneath it produces a known type of multi-day outbreak. A slow climate migration with no acute atmospheric trigger produces a gradual uptick in annual tornado counts that insurance and emergency management can adapt to over years. What we are watching is both at once. An acute atmospheric regime delivering its tornadoes into the exact geography that the long-term climate migration has made most vulnerable. The short-term system and the long-term system pointing at the same map. And the risk from overlap is not additive, it is nonlinear. When two systems meet in the same geography at the same time, outcomes can exceed the sum of the parts. A tornado warning lead time that was already shortening because of rain wrap in hilly terrain gets further compressed because forecasters are on day 5 of a staffing cycle. A tornado that makes landfall in a suburb of Kansas City on a Thursday night arrives at a population that watched Ottawa get hit on Monday and has stopped paying full attention by Wednesday. That is the coverage gap, the framework gap, and the geography gap, all stacked. Strongest outbreak of the season, not yet. Costliest outbreak in history, not yet. The longest continuously active tornado corridor of 2026 to date. Yes. Here is where this leaves us. As of Thursday, April 16, 2026, the Storm Prediction Center is still carrying severe weather risk across the Southern Plains and the Great Lakes. No fatalities have been reported from the April 13th EF2 events. The infrastructure hit has been significant, but not catastrophic. But the atmospheric regime driving this corridor has not broken down. The trough has not moved east. The frontal boundary has not cleared. The dry line is expected to reload again. And the population inside the corridor, roughly 57 million Americans from Wichita to Chicago to the southern shore of Lake Michigan, is now 5 days into a cognitive fatigue cycle that was not designed into any emergency model. The real story is not any one tornado. It is the gap between what the atmosphere is doing and what our frameworks are built to see. A single-day outbreak we know how to handle. A season we know how to handle. A corridor that keeps reopening for 5 consecutive days while the climatological center of U.S. tornadoes migrates into the same geography is something we do not yet have a clean name for. Somewhere tonight in a small town in eastern Iowa, northern Illinois, southern Wisconsin, or the Ozark Hill Country, a family is checking a weather radio for the 5th night in a row. They are tired. The storms have not stopped. The warnings have not stopped. And the compound system, the overlap of a persistent atmospheric regime and a long-term climate migration, is still pointed directly at them. That is where this story lives. If you want to understand how an event like this scales into something far worse, watch our full breakdown of the March 2025 tornado outbreak. The 3.5 days that produced 118 tornadoes, 44 deaths, and $11 billion in damage. The mechanism is the same. The outcome was not. The window is still open.